Okay, so I'm going to pause right here on talking about symmetry to talk about intercepts. We're going to still use 27 to talk about intercepts because it fits so nicely and so pretty. Hey, do you guys know anything about x-intercepts? Okay, what is the most important thing you can know about x-intercepts?
It's when not proper.
Y is 0. What'd you say?
Isn't like it's not like a proper like function.
An x-intercept? Oh, those are vertical lines. Yes, I know what you're talking about, but that's not x-intercepts. So, x-intercepts. Let's see. Let's use green. All right. Could you guys tell me how many x-intercepts this thing has? That's 4. There's one right there. There's one right there. There's one right there. There's one right there. How many y-intercepts does it have? Just 1. Okay, but go back to x-intercepts. What do all these x-intercepts have in common? All of them have a y that equals 0, right? That's all you need to know about x-intercepts. So if I were to look at y equals x squared minus 2x, and I was looking for the x-intercepts, I just need to plug 0 into the y and get busy. Does that look familiar? You're like, oh, how do I start that? Well, factor it. But this is not your traditional 3-term trinomial, polynomial. Instead, you can just factor out a greatest common factor, and this is what you would get. And then you would take each of those factors. Here's a factor. This is a factor. That's a factor. You take each of these factors, set them equal to 0, and solve. You get x equals 0. That one's already done. And the other one, you get x equals 2. Hey, check it out. Check that out. Look, you see this right here? What were the 2 x-intercepts? 0 and 2. Check out my table. Wow. I got 0 and 2 right here. Look at my graph. Hey, it matches up. That's kind of neat. Yeah? Yeah? Neat? Not neat. Yes, neat? Okay, well, what about y-intercepts? What do you guys know about y-intercepts?
There's only one.
This one's not as cool for this problem, but
In functions.
really important. What is a y-intercept? What do all y-intercepts have in common? X equals 0. So if I go back to my function, y equals, or my equation, well, this equation happens to be a function. And if I plug 0 into this, oh, we already did that, huh? I get my y-intercept. What is my y-intercept? 0. Now this one, the origin is on the function, so that means the origin is the x-intercept and the y-intercept. It's not that exciting, but whenever you plug 0 into a function, you find the y-intercept. Look at this number right here, 25. If I plug 0 into that x, what's my y-intercept? 1. If I plug a 0 into this x, what's my y-intercept? 3. If I plug a 0 into this one,
You can't do it.
what's my y-intercept?
Oh,
It'd be square root of negative 3, but you can't do negative 3, huh? No y-intercept. Oh. If I wait a second. If I plug 0 into this one, what's my y-intercept? Yeah, because it'd be negative 6. Absolute value of negative 6 is positive 6. So finding y-intercepts are beautiful. They're so simple when it's a function of x. Question?